In this video, we are revisiting the basics. In this video, I am going to describe in very simple words as how an autoregressive model works. An autoregressive model is a type of statistical model where the prediction of the current value depends on previous values in a time series or sequence, commonly used in time series forecasting and natural language processing tasks such as text generation. You might have seen me downloading and running a lot of text models. Most of them use some variation of this autoregressiveness. An autoregressive model generates prediction sequentially by using its own output as inputs for future predictions, maintaining a dependency on the past values. So let's get started. I will be showing you the code and then I will be explaining the code as we go. I'm using my Ubuntu system for it. One prerequisite you would need is to install the transformers library. So make sure to do pip install transformers-upgrade. I already have it installed, so it should be good for me. Let me clear my screen and let's go to Python interpreter. First thing we need to import some of the libraries, so which will include numpy, time, torch, and also a couple of modules like auto model for causal lm and auto tokenizer from transformers. Auto model for causal LM selects the appropriate model for causal language modeling tasks, while auto tokenizer automatically generates a tokenizer suitable for the specified model architecture. Both are from the transformers library from the Hugging Face. Causal language typically refers to the language that is used to describe cause and effect relationship or events that lead to specific outcomes. In context of NLP or natural language processing, causal language modeling involves predicting the next word or sequence of words in a sentence based on the preceding context, which is useful for tasks such as text generation, completion, or prediction. So let me import it. That is done. Now, as a next step, let's get a model which we will be using for this auto regressiveness. One of the seminal model is GPT-2, which is quite old but still does the work. It is quite small. So let's load its tokenizer and then we will load the model itself. Tokenizer just converts our own text prompt into tokens, which are subwords or words. Let's also get the model, which is quite small. That is done. Let's specify a text prompt. Prompt is simply for the completion that the most beautiful city of Australia is, and we will let autoregressive model to complete the sentence. Let's pass this PyTorch tensor to the tokenizer so that it will convert this whole prompt, the text prompt, into tokens, which is the stuff which is understood by the model. Let's also print the inputs. So this is how it looks like. These are all shapes in the attention mask. Now let's also specify that we don't want to use any sort of gradient. So what this command is doing, let me first put it here and then I'll describe it. So this is a context manager provided by a PyTorch, this no underscore grad. And this is temporarily disabling gradient calculation. This means that any operation performed within this context won't have their gradients computed or stored, which can be beneficial for inference or validation steps where gradient calculation is not needed. And if you are wondering what gradient represents the rate of change of a model's loss function with respect to its parameters, which indicates the direction and magnitude of adjustment needed during training to minimize error and improve the performance. Now, let me press enter here so that we will be setting it up. That is done. Now, in the next step, let's specify our logits. So these are the logits. Let me print them and then I will explain. Now, in very simple words, logits represent the raw output of a model before it is transformed into probabilities. They are typically scores or values associated with each class in a classification problem. Higher logits indicate a higher confidence in the corresponding class, Logits are then passed through a soft max function to convert them into probabilities, which can be interpreted as model's confidence in each class prediction. Now let's also get the some of the last logits, and then we will convert them to tokens. There you go. So you can see we have now 262 as a next token or the next word in this sentence, which we have given as a prompt. Now, one more thing, if you look at these three lines, what is happening here is that we are using argmax function. Argmax is an operation that returns the index of the maximum value in a vector or array. It doesn't compute probabilities but rather identifies a class with the highest score or probability. And here in the context of this one, argmax is being applied to the output probabilities generated by a softmax function to determine the predicted class label. Now, once that's done, let's decode this token into letters or word with the tokenizer decode. There you go. So it has the next token is the. So the sentence was, the most beautiful city of Australia is. So the next token as per this model is the. Let's see what are the top 10 tokens, and we are using top k probabilities here. Let's see what are the next 10 tokens instead of just one. And now let's print them out. We have already decoded them. So next one is the located in Sydney, not now, Melbourne. So you see, out of those 10 tokens, the model could select any one of them. And once model will select it, it will make it part of his input for the next one. So it is auto-regressive, keep regressing to the past value. So this is how an auto-regressive model works. And you can of course play around with it as much as you like. I hope that this short introduction into this autoregressive model was interesting, because I firmly believe that if we want to understand all of this AI and all this stuff, we at least need to have a bit of a high level generic idea around all of these things, especially around these top probabilities, logits, and gradients, weights, and all this stuff. If you still have any confusion or question, please feel free to put it in the comments. And if I have missed anything, feel free to add up to it, because we are sharing this learning journey together. If you like the content, please consider subscribing to the channel. And if you're already subscribed, then please share it among your network, as it helps a lot. Thanks for watching.